So what we're going to do now is when a function is unfactorable, how are we going, how do we find the zeros so that we can sketch a graph? Or just how do we find the zeros so we can actually write a factor form of this function? But before we do that, let's review a few skills. First thing is we're going to review division. So if we have the numbers 37 divided by 3, we know we're going to set it up this way. And then we say, 3 goes into 3, which is the first number. How many times? 1 time. So we put 3 there. 3 minus 3, okay, notice I'm subtracting, is 0. So then I bring down the next number, 7. And then we ask ourselves, 3 goes into 7 how many times? So 3 times 2 is the closest to 7 without going over. And then we put the 6 underneath 7, and then we subtract again. And then we get 1. Now, how do we write this answer? We write it as 12 and remainder over divisor. So let's kind of talk about the different things in here. This thing is called the remainder. The answer to a question is called the quotient. The number you're dividing by is called divisor. And then the number that is being divided is the dividend. Oh, I think I spelled that right, I think. So 12 and 1/3 is the answer. Now 12 and 1/3, another way to think about it is really 12 whole ones plus 1/3 of a whole one, right? We write it as 12 and 1/3 as a mixed number, but that's really what it means. 12 plus 1/3. So you're going to remember how you did that and apply it to long division. So we are going to do long division. So 12 and 1/3 is kind of the answer you write, right? So 12 and 1/3. Another way to write that is basically saying if I took 37 and then I can, or let's kind of write it this way. I can say that this is kind of what we call go around the world. If I want to reconstruct that 37, I would say, oh, it's actually just 3. Oh, let me write it in blue. It's really just 3 times 12 plus 1, which is my original number. Right? So this is the 2 ways to write your answer. One is called the fraction form. And the other way is the polynomial form. Like if you were to reconstruct a polynomial from this, this is what you would do. All right, so let's look at the question. So let's review long division. If we were to take this polynomial and divide by this polynomial, let's set this up. 3x cubed plus 5x squared plus 8x plus 7 divided by 3x plus 2. Okay, we're going to compare the highest degree to the highest degree. So you ask yourself, 3x times what is 3x cubed? 3x times what is 3x cubed? That is x squared. So x squared is going to go on top of the x squared spot. So please make sure they do line up. Okay, so then 3x times x squared is going to be 3x cubed. So put that there. 3x times, I'm sorry, I already did that one. 2 times x squared is 2x squared. So that goes here. You remember in the original question, we subtracted. So we're going to have to do the same. 3x cubed minus 3x cubed is 0, so just ignore that. 5x squared minus 2x squared is 3x squared. Bring down the next terms. All right, do it again. 3x times what is 3x squared? X. So put x on top of the x part. Remember to line it up. So then 3x times x is 3x squared. 2 times x is 2x. Remember, we're subtracting. So 3x squared minus 3x squared is 0. 8x minus 2x is 6x. Drop down the next one. 3x times what is 6x? That is 2. So 6x plus 4, remainder 3. All right, let's go ahead and write the answer in both polynomial form and fraction form. Fraction form is a little easier, so let's start with fraction form. Fraction form is quotient plus remainder over divisor. Quotient plus remainder over divisor. All right, polynomial form is just basically kind of thinking multiply and then add. So if we wanted to reconstruct the polynomial, we would say x squared plus x plus 2 times 3x plus 2 plus 3, and this is equal to the original polynomial. So let's call this p, oops. If we were to call the original polynomial p of x, this is equal to p of x. This is equal to p of x divided by 3x plus 2. All right, let's have you try this one. Divide this by this. So you have kind of slightly harder one. Let me kind of show you how to set it up though. 2x to the 4th minus x cubed minus 2. Is this the correct way to write this? No. If we have missing degrees, we're going to have to put 0 as a placeholder. So we know that there is a space for that. So, oops, sorry. So this is incorrect. We need to put plus 0x squared plus 0x and then minus 2. So make sure you put a placeholder there. For the divisor, it doesn't really matter if you put placeholder or not. All right, go ahead and finish the problem and come back and check your answer. All right, go ahead and check your answers. So hopefully you remember to subtract. This is kind of where a lot of students would get confused. So make sure you do subtract. If you think you're going to forget, you might do what I do, which is write subtract, so you don't forget. All right, now let's review synthetic division. Synthetic division is only possible if the divisor is linear. If the divisor is quadratic, you have no choice but to use long division. So if it's if it's possible by synthetic, here's how we set it up. We put a box here, and then in the box, what we're going to do is put the divisor in. Now we're not going to actually put the entire divisor in. We're going to figure out what number it would be if it really is a possible factor. So if that divisor is x minus 3, then that means x should be 3. So we put 3 in the box. And then what we're going to do is we're going to set this up using only the coefficients to the polynomial. So for example, the first term is 2x cubed, so we just write a 2, minus 3, minus 5, minus 12. Again, if you're missing a term because the degree is missing, you got to put a 0 in as a placeholder. Then I draw a line. This is the equal sign. And then what I do is between the last two terms, or between the last two numbers, I put a line in between. That tells me after this line, this part is the remainder. So it's just a good reminder for myself that this is the remainder. All right, so if you recall, what you're going to do is drop down the first number. Then you're going to multiply that number with what's in the box, which is 6. You put that number in here. Or maybe I should put the arrows in different colors so you can see it. So drop down the first number, take that number, multiply by the box, and then put the number here. This time you're going to add, not subtract. I know this is a little confusing. You're going to add. So then you get 3. And then you do it again. 3 times the box, which is 9. 9 goes in here. You're going to add. So this is 4. Do it again. 4 times the box, which is 12, goes here. 0. All right. It's nice when we get 0. So now what does the answer even mean? Okay, so first we have the remainder, which is after that line. Next, this first term is the constant to a polynomial. And then as we go to the left, we get higher in degrees. So this is first degree, this is second degree. And then if there are more numbers, then it increases in degrees. And then so this 2, 3, 4 are just the coefficients to these degrees. So if we were to reconstruct this 2, 3, 4, which is the quotient of the question, is 2x squared plus 3x plus 4. So that's the quotient. So then if we were to write this in polynomial form or fraction form, it's kind of the same. So 2x squared plus 3x plus 4. Since there's no remainder, that is the answer. So this is what happens when we take the polynomial and divide by x minus 3. If we were to say what was the polynomial, we would say, oh, yeah, it's going to be the quotient times the divisor. Now, it's kind of interesting we got 0 as a remainder, right? So when we get 0 as a remainder, what does that actually mean about this factor x minus 3 or the 0, which is x equals 3? Well, let's get into the remainder and factor theorem. Remainder and factor theorem says very simply, if you take a polynomial and then you divide it by this factor x minus k, you could figure out the remainder instead of dividing and then figuring out, oh, the remainder is 0. You could actually find the remainder a faster way by just plugging x equals that number into the function. So, for example, in this problem that we just did, x minus 3 is the divisor. We said that basically that number would be x equals 3. If I wanted to find out that the remainder really, really quickly, I would just plug it into the function. The function, remember, is the equation. So what I would do is, let's call this f of x. If I want to figure out the remainder, what I would do is just plug that number into the function. Okay, so let's see. 2 times 3 cubed, that's 3 cubed is 27, minus 3 times 9, minus 15, minus 12. Okay, might need to use the calculator on this one. 2 times 27 is 54, minus 27 minus 15 minus 12. So that is 0. Ah, we got the same answer. 0 here, 0 here. So the remainder theorem is saying, hey, if you really just want to find a remainder, you really didn't have to do the long division or synthetic division. You can just plug that number in. And then whatever answer you get, that would be the remainder. And why do we need to even do that? Why do we want to check the remainder? Well, because if you plug it in and you get a 0, that means x equals k is the 0 of the function. What does the 0 of the function mean? That means it divided evenly into the function, meaning this is the number that's going to show up on the x-axis. This is the x-intercept. This is the solution. This is, what other way do we call this? But x equals k is the 0 of the function. Or we can also say x minus k is a factor of the function. So 0 and factor are related. If that number is not 0, then we would say that x equals k is not the 0 of the function because we didn't get a remainder of 0. Okay? All right, let's see how we can use this to help us figure out how to factor or find the zeros of the function. So let's say, for example, we have this function here. Determine the factors of this function. So which ones are the factors? And then the graph is shown below. All right, so let's kind of analyze everything we know about this function before we start. First, this is cubed. That tells me we should have 3 zeros. It does show up as 3 zeros on the graph. We have -3, 1, and 3.4. 3.4 is a little strange. I'm not sure what 3.4 is in the factor form, so I probably had to kind of think about it a little bit. I know that -3 is a 0. That means if I plug -3 into the function, I will get 0 out, which, it kind of tells me that it is 0. So I know that -3 and 1 are the zeros. I don't know what this is. So what I'm going to do is actually use synthetic division to divide out every zero, so then I can figure out the last factor. So I know one of the 0 is -3. So what I'm going to do is use synthetic division, and then I'm going to divide it out. So remember, synthetic division and long division are just ways to divide out a factor or a 0. Okay, so again, drop down the first number, multiply, -15, add them, -22, multiply, 66. 66 minus 49 is 17. 17 times -3 is -51, 0. And I should get 0 because I know it is the 0 of the function. Next, I know the next 0 is 1. So what I'm going to do is from here, I'm going to continue dividing the next 0 out. So I don't want to start from the beginning because I already know that it will work. I just want to figure out what this last factor is. And so I just take the function, divide one thing out, take the leftover, divide the next thing out. All right, same thing. Drop down the first number, multiply. You get 5. -22 plus 5, -17. So multiply, you get -17, 0. All right, great. So we got to the last part. Reconstruct the quotient as a polynomial. 5x minus 17. 5x minus 17 is my last 0, and so, sorry, last factor, so that means the 0 is going to be 17 over 5, which I wouldn't have been able to figure out if I just didn't do this synthetic division. So then the question says, determine the factors. So sometimes you had to kind of look at the words a little closely. They want the factors. So I know that the factors have to do with the zeros. So if x is equal to k, then the factor is x minus k. So I have 3 zeros. X equals -3, x equals 1, and then x equals 3.4, which is, I said it was 17 over 5. Okay, let's reconstruct the factors. This one must be x plus 3. This is x minus 1. This one, if you said it's x minus 17 over 5, that would be correct, except it's not quite correct because the factor is actually 5x minus 17. Why is it important? Because you're hitting the x-axis at the same place, but you have a different coefficient. And so that means it's going to create a different polynomial. So if we were to actually write this out, we would say this is in the factored form x plus 3, x minus 1, and 5x minus 17. Because if we were to multiply this whole thing out, we would get this polynomial back. Now, what if you can't you graphed it or you don't have a graph and you have to start guessing what the zeros are, then what are you going to do? Well, we can use this theorem called rational zeros theorem or rational roots theorem to give us the best guess of where to start thinking about where the roots are. And then if you recall this from last year, this is how you do this. When the function is in the polynomial form, you usually have a constant at the end, and then you have a leading coefficient in the beginning. So then this is the P over Q method, if you recall. So what you would do is you find the integer factors of A naught, that is the constant part, and we call that P. And then we find the integer factors of AN, which is the leading coefficient, and we call that Q. And then so plus or minus P over Q are all the possible rational factors of the function. Is it the factor? We don't know, but it's possible. All right, so let's look at one example. Find the zeros of the function. Before you do P over Q, you always ask yourself, can I actually factor this one? No, you cannot factor, so you have to start by guessing. All right, we know P has to do with the constant, and Q has to do with the leading coefficient, so plus minus P. What are all the factors of -1? That is plus minus 1. What are all the factors of the leading coefficient? 6. That is 1, 2, 3, and 6. So what you're saying is what numbers multiply together to get 6, or what numbers, when you multiply them, you would actually have a chance of getting 6. Okay, now list them out. Plus minus P over Q. So that is plus minus 1, plus minus 1/2, plus minus 1/3, plus minus 1/6. So if you look at it, each one has a plus minus, and there are 4 of them, so that's a total of 8 possible numbers. How many factors are there, or how many zeros are there? 3. So there are a lot of them that are not going to work. So which one is going to work? We don't know. How do we start guessing? We use the remainder theorem. Remainder theorem says if it works, then the remainder should be 0. So let's start guessing from number that's kind of easy, right? So maybe 1. Try our luck on this. So if we put 1 in there, we get 6 minus 5 minus 1. Oh, we got really lucky. 0. So 1 is a factor, or 1 is a 0 of the function. So you don't want to continue guessing the next 7, because once you get 1, that's really, really good. What you're going to do is use synthetic division and then divide it out. That way you have less things to work with. All right, so synthetic division. Let's put it into synthetic division. 6, 0, because you have no x squared term, minus 5, minus 1. All right. Drop down the first number, 6, multiply, you get 6. Add down, 6, multiply, 6, 1, 1, 0. And you should get 0, right? Because you already checked. All right, so reconstruct. 6x squared plus 6x plus 1 equals 0. Now what? Should we continue checking the 7? No. What should we do? Well, this is kind of nice. This is second degree. We have so many options with second degree, right? We can factor if it's factorable. If we cannot factor, we can always use quadratic formula to figure out the answer. So go ahead and figure out the rest of the 2 zeros. All right, go ahead and check your answers. So this one, you had to use quadratic formula, and so you get this answer here. All right, let's go ahead and have you practice. Find the zeros of this function. Remember, the first thing is you glance at it and say, can I factor with anything I know before I get to P over Q? It's not possible. So you're going to have to use P over Q. And this one is nicer because I think you don't have that many to choose from. But anyways, once you do P over Q, okay, so start with P, Q, and then P over Q. Once you do that, remember to use the remainder theorem to check your first one. If you get one, then just use synthetic division, divide it out. It's much faster than keep checking all of them. All right, go ahead and pause the video, do it, and then come back and check your answer. All right, go ahead and check your answers. So I got very lucky. I guessed my first zero as 1, and then it does work. And then this is actually factorable, so this is very nice. So these are the 3 zeros.